Welcome back. This is 7.3 combinations. So our objectives are to distinguish between permutation and combination problems, solve problems involving combinations using the combinations formula. All right, combinations are a combination of items occur when the items are selected from the same group. No item is used more than once, and the order of the items makes no difference. So just a side note, permutation problems involve situation in which the order matters. So just make sure that you remember that. So combination problems involve situation in which the order of items makes no difference. Okay, so combination, no difference. Permutation, it does matter. All right, it says determine which involve permutation and which involve combinations. So it says 6 students are running for student government president, vice president, and treasurer. The student with the greatest number of votes becomes president. The second highest vote gets vote getter becomes vice president, and the student who gets the third largest number of votes will be treasurer. How many different outcomes are possible? All right, so the matter does order because it's going from highest votes to least votes, and then the highest number of votes determines the office. So it does matter the order, so it's going to be permutations. All right, next, 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? So since there's no offices and since there's no order of voting, it's going to be a combination. All right, next is Baskin-Robbins offers 31 flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. So how many bowls are possible? So it doesn't matter which scoops you get. It's just those 3 scoops, and it doesn't matter the flavor because and the order is irrelevant of which ones they go in order. So, for example, if you have a chocolate vanilla strawberry, it's the same as a strawberry vanilla chocolate. Unless you really do specify that's the order you want it in, then that would change to a permutation. But since it doesn't specify that, it's going to be a combination. All right, comparing combinations and permutations. So given the letters A, B, C, D, we can compare how many permutations and how many combinations are possible if we choose 3 letters at a time. So the combination of A, B, C, so those are all the possibles. The columns A, B, D, A, C, D, and B, C, D. So it tells you that those are the columns for each. If you did all 4, then and you didn't specify the order, still would be that combination. All right, formula for combinations. So it says combination of n things taken r at time. R at a time. So it says the number of possible combinations if r items are taken from n items is n CR, which means you have n factorial divided by n minus r factorial times r factorial. All right, example 2, it says using the formula for combinations. So it says how many 3-person committees could be formed from 8 people. So you're selecting 3 people, so that's your R. And then the 8 is your N, so for how many. So 8 factorial over 8 minus 3 factorial times 3 factorial. So we have 8 factorial. 8 minus 3 is going to be 5. So 5 factorial times 3 factorial. So remember, we can write this out. So we have 8 times 7 times 6 times 5 factorial, because remember, we want to match the number on the bottom. So we can cancel out that 5 factorial. So you have 8 times 7 times 6 divided by 3 times 2 times 1. So you would put this in parentheses in your calculator, and you would get 56. So that's how many different committees you could have. All right, next it says in 2017, the U.S. Senate consisted of 46 Democrats and 52 Republicans and 2 independents. How many distinct 5-person committees can be formed if each committee must have 2 Democrats and 3 Republicans? So first we need to find out how many, picking 2 Democrats out of 46. So that's that 46 factorial, 46 minus 2 factorial, and 2 factorial. So you have 46 factorial over 44 factorial times 2 factorial. So you have 46 times 45 times 44 factorial over 44 factorial 2 factorial. Let's cancel out the 44. So you have 46 times 45 over 2 times 1, which is just 2. So 46 times 45 divided by 2. And you put that in your calculator and you get 1,035. All right, you do the same for the Republicans. So 3 out of the 52. So you'd have 52 over 49 times 3 factorial. So we have 52, 51, 50, 49, because we want to match that bottom number, or the denominator number. So you'd have 52 times 51 times 50 all over 3 times 2 times 1. And if you wanted to, you could change the bottom. 3 times 2 times 1 is 6. So you have 52 times 51 times 50 divided by 6. So I would put parentheses around that when you put that in your calculator. So if you put it in your calculator, you're going to get 22,100. All right, then you're going to multiply those numbers together. So that would be the committee together, how many possible combinations of the 2 of those. So you would do 1,035 times 22,100. Putting that in your calculator, you're going to get 22,873,500 different ways that committee could be formed. All right, and that is it for 7.3. If you have any questions, please let me know. Otherwise, go ahead and work on your assignment.